Hey guys, I'm posting this video as a follow-up to Lab Exam 2. So we have our statistics up here. The average was about a 71.4%, which is great because that's exactly where we wanted it to be. We did want this average to be a little bit lower, especially because the first lab exam as well as the first midterm had pretty high averages. They were about 82% and about 79% respectively. So we did make this one a little bit harder. So that's definitely a good average right there. That being said, however, the median was a B, an 85%. And out of 19 students, we had 9 A's, and 7 of those were 100. So make what you will of that statistic. I'm not going to lie, we did get some pretty low grades. I'm not going to tell you what the lowest score was, but that definitely did balance out very strangely. So moving on to the actual content. So there are a few things that we had to handle while grading. The first thing was hard coding. So a lot of these things that I'll talk about later, we expected you to be able to execute with a loop or basically with a loop or with recursion. So if you did hard code it, we did give you credit if the output was correct. But that being said, I don't think that we encountered uh, barely anyone who hard coded and actually got the correct output. Just because if you're doing it at that point, you are probably going to miss some detail. Like we had a lot of missing equal signs, a lot of missing quotations, things like that. So just keep that in mind. We did give you credit if your output was correct. Okay, so also using forbidden operands, so things like if you didn't use recursion in the second problem where we specifically asked you to use recursion, we gave you half credit if your output was correct. And if your output wasn't correct, then we didn't give you anything at all. So that's basically how that worked. All right, so just to talk a little bit about the problems. The first problem was you were asked to program concentric circles in Canvas. So the radius of the largest circle began at 100 pixels, and each consecutive circle had a radius of 3/4 the size of the previous one. So basically, this is kind of what we expected you to set up. Basically, you had a radius was initialized at 100, and this was important. We had a lot of problems with integer division here. So it depends on how you set this up. If you multiply by 0.75, that would be fine as well. But this is important if you're going to use a division operation. So I just put that there. And so this should have been your quote base case of sorts or your condition for your while loop. Basically, just like Sierpinski's triangle, you know that we cannot subdivide a pixel. So the bottom line should be that if your radius is less than 1, then you should stop. So that's when you would return something here. And I guess that you would actually have something like return nil right here because we did ask you to do that. But this, like I said, you could handle this in a number of ways and it would still be correct. Okay, so the second problem was exponentiation by recursion, and like I said, we did ask you to specifically use recursion with this problem. So if you use a loop or use the exponentiation operation, we did look through your files for that. So anyone who did that and got the correct output, we only give you half credit. If you didn't get the correct output at all, then that was nil points. So this is essentially what your code should have looked like since we did give you the formula. So your base case should be that if your exponent is equal to 0, then you return 1 because anything raised to the 0th power is 1. And so otherwise, you should have your base times the second function call with the exponent reduced by 1, and that will eventually taper down to 0. So that's how that was handled. All right, so number 3 and number 4 had to do with um, binary values and hex values. These were a little bit more complicated, but we did assign these for homework, and we did warn you that we were going to put these here. So we did suggest you to finish or at least understand your homework before the lab exam. So we did make this a little bit easier on you. This first one was basically saying that if you have a binary string of 4 bits, then you should be able to turn it into some hexadecimal value. We also provided those values for you in the form of an array. I'm using an instance variable here in this code just because I was lazy. Basically, what this allows me to do is to call this within this file. So it should look something like this. Again, you did this in your homework. So you initialize sum total is 0. Your index should be initialized to 0, and you can initialize sum power to 3. because your indices are going to go this way while your powers are going to go the other way. Um, so basically, you have this kind of, for the first index, it should be raised to the power of 3, which is 8. And then moving down as the index grows, the power decrements. Okay, so you have some kind of loop here set up when, while it's less than the length, or you could have less than 4 as well, do this. And if it is 1, you want to add this power to the total. If not, you just skip it, and then you would increment index by 1 and decrement power by 1. And then in the end, you would return this, and you would essentially treat your total, or treat all of your hexadecimal values as an index. And your total will come out to be, if it's anything more than 9, it would be treated as 10, 11, 12, etc. For the indices of the letters. 4 was also, we wanted to see that you understood what these functions were doing and that you were able to call them and come up with a more complex function out of these little functions. So basically this is saying that if you have a hex string of, or a binary string, excuse me, of any length, then you should be able to, using this function that you previously wrote and this function that we gave you, you should be able to basically output the hex string of this, uh, regardless of how long this binary string is, or regardless of whether or not the length is a multiple of 4. So we did give you the substring thing, which will basically output each binary string of length 4 and kind of separate those for you so that you will be able to call this function earlier. So essentially how we graded this was that if you did not get number 3 right, but you still got the idea right for number 4, we gave you credit. Basically, you should know how number 3 should be working, so that will allow you to theoretically call it even if you weren't able to write it. So yeah, basically that was how that was handled. You didn't have to call these if you didn't want to. You could have done this some other way, but this would be the way that you would write this function if you were to call both of these. So that's pretty much it for this follow-up. If you have any questions or concerns, again, always just email me, Greg, Guna, or Andrew, and we will definitely take a look at your scores and get back to you. But that's pretty much it for now, and we'll see you guys tomorrow.